Hi, everyone. My name is Alison Jing from the Empathic Computing Lab of the University of South Australia. I'll be presenting our work titled Using Speech to Visualize Shared Gaze Cues in MR Remote Collaboration. In this paper, we present a 360 panoramic mixed reality MR system visualizes shared gaze cues using contextual speech input to improve task coordination. We conducted 2 user studies to evaluate the design of the mixed reality gaze speech interface, exploring the combination of visualization style and context control level, enabling interaction via a live 360 panoramic video-based MR environment. Our system uses multimodal input methods to visualize and exchange shared gaze cues between a local augmented reality user and a remote virtual reality collaborator. It uses eye tracking to capture the shared bidirectional real-time gaze cues and combine them with speech input. There are 3 shared gaze behaviors, including default browsing state to indicate active eye movements, a focus state to show an eye dwell, and a joint state to indicate neutral attention. 3 MR interfaces are designed to show joint gaze indicator, visualized through a virtual connection between collaborators' current gaze point from a subtle to obvious in arrow pointer, screen edge pointer, and ray pointer. The indicators we trigger when in situ keywords are spoken by either collaborator, detected by Windows Speech Recognition API. The goal of the first user study was to evaluate the design of the 3 MR joint gaze indicator interfaces to understand how the level of visual obtrusiveness would affect the representation of contextual speech input. 12 participants aged between 22 to 33 years old were recruited. 58% identify themselves as frequent AR/VR users. If within subject design was employed to evaluate 3 MR interfaces. In each condition, a pair was expected to collaboratively find duplicated symbols in both local and remote roles. Both qualitative and quantitative measures were used, including post-condition rating items, cognitive load question, post-role preference rankings, and post-study semi-structured interviews. I'll play a small demo clip to showcase the conditions briefly. This is a read pointer, triggered by this one I'm looking at. Arrow pointer, screen edge pointer, ray pointer. Findings from the first study suggest that an explicit visual form that directly connects the collaborator's shared gaze to the contextual conversation is preferred. However, having an explicit joint gaze indicator available all the time may add extra cognitive load during task collaboration. Therefore, the display styles and the modality of the context control may need further investigation. This led to the second study. A second study was conducted to understand how to combine the joint gaze indicator display styles with the different levels of context control to positively affect task coordination. 24 participants in 12 pairs with ages ranging from 19 to 42. Half of them reported themselves as never to slide AR/VR users. 58.3% indicated that they had never to slide experience with general gaze interfaces. 4 conditions were designed using different combinations of attributes in context displays and control modalities. They are joint indicators always on, indicator disabled, indicator controlled by contextual speech, and controlled by eye dwell. Participants had a separate reference showing only half of the symbols and were expected to combine given information to locate 4 consecutive symbols collaboratively. We created a gaze behavior metrics, which consists of completion time, joint time, coordination time, browse time, and local and remote coordination. Post-condition surveys, including social presence, collaboration experience, and open questions are included as well. To conclude, a system usability scale and post-study preference ranking were also included. I'll show you a brief video for the study as well. So this is joint gaze indicator always on. This is no joint gaze indicator. And this is the controlled by eye dwell. And we have already seen the one controlled by speech earlier. The second study indicates that the gaze speech modality shortens the coordination time to attend to the shared interest, making the communication more natural and the collaboration more effective. Qualitative feedback also suggests that having a constant joint gaze indicator provides consistent bidirectional view while establishing a sense of co-presence during task collaboration. There are some limitations to our study nonetheless. The before marker used to align AR and VR coordination system had limited tracking accuracy. The Windows speech recognition is cloud-based that has about 0.3 seconds delay and accent recognition issue. Lastly, the study were conducted in a lab-controlled environment lacking real-world practices, and the performance can be affected by individual communication problem-solving abilities. To conclude, in this work, we present a live 360 panoramic video-based mixed reality system that uses contextual speech input to visualize shared gaze cues between remote collaborators. Using this system, we conducted 2 studies to evaluate the design of gaze-speech interfaces and how different modalities should be combined with conversing context during task coordination. The result demonstrated that explicit visual design provides a direct connection between context and shared gaze cues. The gaze speech modality has made communication more natural, and since the key phrases are embedded in a conversation, when gazing at an in situ target, and they only appear when the need for joint attention is signaled through speech. Meanwhile, constant joint gaze indicator provides a bidirectional view where users can subtly attend to each other's current focus without using additional input modalities, while establishing a constant sense of co-presence. When designing gaze UI, symmetrical visual feedback should be considered to ensure a remote collaborator acknowledging messages being successfully delivered both ways. In the future, we plan to explore other modalities such as gestures and physiological cues to support sharing gaze in mixed reality remote collaboration. Doing so will help us further understand how shared gaze cues support or compensate for other communication methods in a variety of task contexts. Thank you very much for your time, and you can reach me at my email or my portfolio as shown above. I'm also looking for research internship exchange programs as well as postdoc opportunities should you be interested in my work. Thank you very much for your time.